Hi everyone, my name is Xiang and my matrix number is A20B1423. Now I would like to present the introduction of Assignment Business Statistics AFT 2103. The topic that we have selected to study is the fuel consumption of vehicle per 100 kilometers will affect the travel distance and the total number of engine cylinders. We take data from online database so that we can save our time that is spent on collecting data. We choose 85 samples from 393 observations that we have researched from our secondary data source. As we know, there are three quantitative variables from dataset research. The first variable of Y in this dataset is fuel consumption per 100 kilometers. However, the two variables of X are travel distance and total engine cylinder of each vehicle.
Hi everyone, my name is Chung Yi Ru with number matrix A20A1306. Now I am presenting the data description. The table shows the group data for the travel distance and total cylinders that impact vehicle fuel consumption per 100 kilometers. We can see that there are 85 sample size of the data set that find from online database. We have three variables. By variables, Y is fuel consumption per 100 kilometers. However, the variable of the first X is travel distance, which is KPL, and the variable of the second X is total cylinders. Organizing data. This is the ungroup data for the variable X2, which is total engine cylinders. So we need to find the frequency distribution of variable X2. However, this is group data for variable X1 and Y, which are travel distance and fuel consumption per 100 kilometers. Next, we need to find the relative frequency and cumulative frequency. So, the formula of the relative frequency is divide the frequency of F by the sample size of N. However, the cumulative frequency of the last class is the sample size of N, which is 85.
My name is Xiang with number matrix A20A1585. I will continue the numerical descriptive measure. In this part, we are presenting the measure of standard tendency, mean, mode, and median, measure of position, first quarter and third quarter, and measure of variation, standard deviation, variance, and range for three variables, which are two variable X and one variable Y. Formula for mean variable X1 travel distance is all variable X divided by total entry. Meanwhile, for variable X2 and variable Y is the sum of frequency of class multiple with midpoint of class divided by total sample size, which n. The answer is presenting in the slide. To find the median for variable X1 travel distance, first determine the location of the median class by using total sample size divided by 2. Therefore, the median class is 90 to 23.90. Next, determine the lower class boundary, which is 80.95. Third step is determine the class size or class width, which is upper boundary minus lower boundary, and the answer got 5. The step 4 is determine frequency of the medium class and the cumulative before median class, and the answer is 90 and 33. Lastly, we substitute the variable we found into the median formula and get the answer is 21.45. For the variable X2, the first step is same as variable X1 and found the median class is 6. Since the observation 42 and 43 are the same value, which is 6, hence the median is 6. For the variable Y is exactly same step with variable X1 travel distance, and the answer is showing in this slide. The mode for the variable X1, first step is determine the location of the model class, which is based on the highest frequency. The answer is 40 to 80.9. Step 2 is determine the lower class boundary, and the answer is 30.95. Step 3 is determine class, which is upper boundary minus lower boundary. Step 4 is determine the difference between frequency of model class and the frequency of the class before model class, and the difference between frequency of model class and the frequency of the class after model class. Lastly, substitute all the variables into the mode formula and the answer gets 70.7. For variable X, the first step is also same with variable X1 and found the mode, which is 4. For variable Y is using the same step with variable X1 and the answer is showing in this slide. The measure of position part. To find the first quarter and third quarter for variable X1, the first step is find the location of Q1, which is total of sample size divided by 4. Then we know the class interval is 40 to 80.90. The second step is find the cumulative frequency before the class interval and the frequency of the class interval, which are 9 and 24, and substitute the variable into the first quarter formula, and the answer is 60.5021. To find the third quarter is using 3 multiplied by the total of sample size and divided by 4, and we got the third quarter position, which is 63.75. Then the second step is same with the first quarter and substitute into the third quarter formula, and the answer is 33.2556. For the variable X2, the first step is arranging the data in ascending order, and step 2 is find the location of Q1, which is total sample size plus 1 and divided by 4. The answer is 21.5. Then find the value for Q1 by using the value for 21 position plus 0.5 for the difference between 22 position and 21 position. The answer is 4. To find the third quarter is same with the step to find the first quarter, but the difference is to find the position is using the formula 3 multiplied by total sample size plus 1 and divided by 4. For the variable y is absolutely same with variable x1, and the answer for all variables are provided in this slide. The measure of variation part. The formula for range is maximum data entry minus minimum data entry. The formula for variance and standard deviation is presenting in the slide. The first step is find the value of x squared, fx, and fx squared for every classes by using table form. The table is shown in the report. Next, substitute all the value into the variance formula and the answer was calculated. They have some difference of sum of x and sum of fx between group data, which is variable x2, and group data, which are variable x1 and variable y. For the standard deviation is the square root for the variance. The answer is showing in this slide. That's all for my presentation for numerical descriptive measure part. Thank you.
We use two variables, which are x1 and x2, to draw our graphical representation. The first of the variable x1 is travel distance. Based on the table then, it can be seen that there are 7 types of class in travel distance, and we use graph or GIF. The plot point of the or GIF graph is represent the class midpoint and their corresponding cumulative frequency. The graph should start at the one class before the first midpoint, which is 6.45, by the cumulative frequency is 0, and it should end at the point of the class by cumulative frequency is equal to the sample size, which is 85. The variable x2 is total NG cylinders. Based on a table and graph, it can be seen that there are 6 classes in total NG cylinders by using histogram graph. The graph shows increase slightly, then further decrease, and finally increase again. Based on the graph, the most total NG cylinders that use are 4 cylinders with frequency of 38. However, the least are 7 cylinders by the frequency is 0.
This part representing the statistical analysis using software, which include numerical descriptive measure, hypothesis testing, correlation analysis, confidence interval, and prediction modeling. This slide is showing the measure of center tendency by SPSS software and the calculation in 3.1. There is some difference between SPSS software and the calculation in 3.1. The difference is already presenting in this slide. However, all the value for variable x2 is the same with the SPSS software and the calculation in 3.1. This slide is showing the measure of position. There is some difference between SPSS software and the calculation in 3.2. The difference is already presenting in this slide. However, all the value for variable x2 is same with SPSS software and the calculation in 3.2. This slide is showing the measure of variation. There is some slightly difference between SPSS software and the calculation in 3.3, just having difference in the range of 2 only. The difference is already presenting in this slide. Overall, there are differences between using SPSS software and calculation in 3.0. This is because the calculation in 3.0 is in 4 decimal places, meanwhile SPSS software is calculated in the real value, maybe in 10 decimal places or more. So there will be some differences between calculation in 3.0 and the calculation by using SPSS software. Slide is showing the graphical representation. The graph generated by SPSS software is exactly the same with graph drawing in 4.0. This is because the table generated by SPSS software is same with table in 4.0. That's all for my presentation for the statistical analysis using software. Thank you.
Hi, my name is PERUMAL and my metric number is 820B1310. I want to explain about the hypothesis testing. In this testing, we have to do 5 steps. The first step is hypothesis. HO, the null hypothesis, equals to nu1 equals to nu2 equals to nu3. The second is HA, alternate as hypothesis, equals to at least one of the mean is different from the others. And second step is significance level donated by alpha. So we use 0.05 as alpha in this testing. In step 3, test statistic. So we need to do the ANOVA test in SPS to do the 4th and 5th steps. And in step 4, decision rule, reject HO, the null hypothesis, if the F is greater from F alpha, comma V1, comma V2. The V1 and V2 is we have to take from the table from second row. So the critical region is F 0.05, 4, 80 equals to 2.49. So this 2.49 is we get from the statistic table. The last step is decision or conclusion step. So reject HO, the null hypothesis, since the F is greater from F 0.05, 4 and 80 is 60.854 greater than 2.49. So therefore, there is a significant difference among the treatments. The test result from the SPS. We can see the group means different statistically because of the signification value is too tailored and the equal variance assumed are less than the equal variance not assumed. Aside from that, if Leibniz test significance of P 0.05, then the equal variance t-test results are assumed. This is the normality test. Two normality tests are performed here. We use the Shapiro-Wilk and Kolmogorov-Smirnov test. The Shapiro-Wilk test is used in our case because we only have 85 elements. The p-value is 0.000, which is lower than 0.5. We can reject the alternative hypothesis and conclude that data is normal. Thus, the assumption of normality of the residence terms is not met. This one-way ANOVA test. One-way ANOVA test was performed to compare the effect of KPL travel distance and cylinders on liter per 100 km. There is statistically significant difference between the groups' means. The significant value is 0.050, which is below than 1. Therefore, there is a statistically significant difference in the mean of vehicle fuel consumption for per 100 km between the KPL travel distance and cylinders. 4. We do correlation analysis. This is the table result from SPSS. The R value between liter per 100 km and cylinder is 0.853. KPL travel distance and liter per 100 km is negative 0.792. So both are greater than 0.3. So liter per 100 km is associated with both cylinders and KPL travel distance. The R value between KPL travel distance and cylinders is negative 0.792, which is less than 0.85. So there is no problem of multicollinearity. Lastly, model summary table. The R value is 0.904, which means 90.4% of the variation in liter per 100 km can be explained by KPL travel distance and cylinders. The adjusted R square is 90.1%. The Durbin-Watson statistic of 0.904 is below from 2, which means it indicates that a positive correlation. Thank you.
Hi everyone, my name is YING. My metric number is A20A1307. I will present the part of the confidence interval. Based on the data above from SPSS, the 95% confidence interval for KPL is negative 0.178 and negative 0.128, where the value of 0 does not fall within the interval, again indicating KPL is a significant predictor. It also represents the standard area for the KPL is 0.013, whereas the 95% confidence interval for the cylinder is 0.194 and 0.413, while the value of 0 does not fall within the interval, again indicating cylinder is a significant predictor. It also represents the standard area for the cylinder is 0.055.
Next, I will present about prediction modeling. Based on the correlation table, refer the column unstandardized p-value. The multiple regression mode is stated on the slide. From the multiple regression equation, B0 is 6.753, a constant or intercept y which reflects the number dependent variable is liter per 100. Next, B1 refer to KPL which is negative 0.153, while B2 refer to cylinder which are 0.303. Thus, for every increase in KPL will drop by 0.153 provided by the cylinder remain unchanged. Similarly, for every unit increase in KPL, cylinder will go up by 0.303 provided the liter per 100 is still same of the KPL.
In conclusion, 85 samples were randomly selected from the secondary data of 393 populations. In order to measure whether we have an actual statistic, we have to follow all the steps and make sure we have no data left. In addition, this task includes the measurement of central trait. We use its own formula, mean, median, mode, measure of variation, sample variance, sample standard deviation, and positional measurements. We also use SPSS to solve and analysis numerical descriptive measurement, hypothesis testing, correlation analysis, confidence interval, and finally to describe and resulting equation in regression.